Welcome to Computer Vision Streams. I'm your host, Ton, and today we will discover an interesting application of this great open source model from Facebook, from Meta. Meta Segmentation Model version 2. This is the model that could segment any kind of object, and what is most importantly, it could track segmentation mask across multiple frames of the video, as you can see in those examples. We can see a couple of examples, the objects, and those are very complicated interactions. In some examples, we even can see that model could work with occlusions very well. You can see that with these shoes, occlusions when the objects are going out of frame and so on. Let's go one level complexity further. Let me show you this example. We will take a group where persons will change positions a lot, where one person will close another person almost completely, very often during the dance, and our goal will be to make semantic segmentation. Let's see how we will do that. For that, we installed a Jupyter notebook in a simple Docker with pytorch-based image, and we will install segmentation model from its official repository, and we will go to the examples notebooks, and we will see video predictor example that I modified a little bit. We don't use Colab, so for our use case, we will just need to download checkpoints of the public large model. Next, we will set up this model from the default configuration. First thing that we need to do is to prepare a video. For that, I extracted a couple of seconds of dancing video, and using this command, I split those video into separate frames. Here is an example of a frame. Next, we will initialize the states of the segmentation model by embedding every image by using function predictor init state. Important part for consumer-grade GPUs without a lot of GPU memory, and if you want to treat quite long videos, is to use those two parameters, to offload video images to CPU and to offload state images to CPU. That will ensure that you are not getting out of memory error. Next, we will reset the state, and we can add visual prompts. Visual prompts could be added as points, bounding boxes, and masks. For my use case, I played with points, and what I found out that it's good enough to have 2 positive points for each object. Here is an example of segmentation masks that I had for initial position of the dancers, and you can see this follow is marked by these 2 positive points. So for every object, we need to initialize object ID, coordinates of the points. In order to easily find coordinates of the points, you can open the frame in any editor, such as Photoshop or GIMP, and then somewhere on the left side, when you point at any point, you will see the coordinates. And you can fill the coordinates quite fast for your initial frame. Then for each point, you need to assign either positive click or negative click. Positive click means that the point belongs to the object. Negative click, that means that point doesn't belong to the object and belongs to the background. Next, I created a dictionary for every object. Every odd object is a leader. Every even object is a follow. And I added all these points with the function add new points or bounding box. And here we have example of masks predicted by segmentation model for initial frame. Here you see that a couple of objects have the same color, but it's just a back of visualization function that has color map for smaller amount of objects that I have initially. Here you see that the masks are quite well, except maybe for this use case, because I just proposed a couple of points on the left side and Maybe if we will add another point just for this leg, that will work better. But anyway, it's good enough to understand the position of every person. Next, we will propagate those masks to all other frames. And here it will be important that we offload both images and internal states to CPU to avoid out-of-memory error if you don't have big GPUs. We call predictor propagate in videos, and we collect the information about video segments. And then we can visualize a couple of frames to ensure that, for example, our green object is consistent throughout movement, and after passing through different occlusions, we still have our dancer tracked, and what is most importantly, we have a good segmentation mask of every dancer. For some background dancers, we could lose the mask during tracking. This could be solved by adding additional points to some later frames, or maybe it could be ignored if you compute some metrics that this object was not visible enough. For the further analysis, we can extract both bounding boxes and masks for every frame, and then we can use, for example, those bounding boxes and masks to improve some other algorithms, for example, to improve 3D pose estimation. Let's see this example of a simplex model fitting. Here you see we had an initial bounding box that didn't cover the hand, and it was not able to fit the position of the hand to the correct initial position. But after I created a segmentation mask specifically for this dancer, we segment anything model, and then make a second inference of simplex 3D model fitting, I was able to drastically improve 3D pose estimation. But this model we will see in the next episode. For now, the interesting metric that could be used for analysis of the choreography is camera visibility metric for every dancer. We can define this camera visibility metrics as the current segmentation mask area divided by the base area, which will be the segmentation mask from the first image. And we can compute this camera visibility metric for every frame. It might be a little bit noisy, so we can make a rolling average to smooth out the curves. Here, what I show just a couple of couples, just to give you the idea of how it could be used. So here you see that we have dancer 1 and dancer 3, which are both male leads, and their visibility is smaller than the initial segmentation mask. And that is actually very good for the choreography, because we see that at every point in each couple, we can demonstrate our girls better in the dance, and that is finally the goal. But here we see we have some problem around the frame 400. Let's see what it will give us. So we saved all the predicted frames, and if we will go to the frame 400 and continue to observe the results a little bit, we see that our dancer in the purple color will be covered by the leading couple. And that is exactly this drawdown of camera visibility. And that is one interesting metric that could be computed from those masks. We can compute much more interesting metrics, for example, post-synchronization and synchronization with music, but that we will see in the next episode. If you are interested in application of segmentation model or any other computer vision project, please write to me in LinkedIn or in YouTube, and I will be able to help you. Subscribe to my channel, and I will see you in the next episodes.